Greetings and welcome, friends. Mr. Waddy here today. We're in section 6.5. We're talking about indirect proof, which is also sometimes called proof by contradiction. And then we're going to use that to make claims about inequalities in one triangle, inequalities in a single triangle. All right, and so first of all, we've got kind of what the concept is behind an indirect proof. All right, it says identify the statement you want to prove. Okay, so there's something that I want to have be true. All right, so some statement that I want to be true. Okay, assume temporarily that it is false. So I'm pretending, guys, right? We're pretending that it's false. I don't really believe that it's false. I'm pretending that it's false. Okay, I want to make sure you guys are on the inside of what I'm doing here. All right? So we'll temporarily assume that this statement is false by assuming that its opposite is true. Okay? Reason logically until you reach a contradiction. What? Right, craziness, right? Until you get some statement that is impossible, illogical, does not make sense. Point out that the desired conclusion must be true because the contradiction proves that the temporary assumption was false. All right, proof by contradiction works by having a double negative. All right, I start with something, I prove that that's false, and that means that the opposite of it is true, which is what I was setting out to do. So what is true is the original statement that I wanted to be true. Proof by contradiction. It's a little bit of a weird idea. All right, it's kind of backwards thinking. It's basically like playing kind of like the devil's advocate for a minute to then, prove that that reasoning doesn't work out. So let's do this. Writing an indirect proof. Oh, that means I've got to do writing today. Well, you guys do too, so here we go. Write an indirect proof that in a given triangle, there can be at most one right angle. Okay, so I've got triangle ABC exists. All right, that's given. All right. Yeah. The book is doing like a paragraph proof, but we'll just do 2 column. All right. Let's say triangle ABC. Let's say angle A and angle B are right angles. Yes. After we start an assumption that's the opposite of what we want. Yeah. That's pretty fun. So this is our assumption. Assume. All right, would be the reason that I'm making this claim. So I don't believe this is false. I don't believe this is true. I believe this is false, but let's pretend it's true for a minute. Okay, so I've got triangle ABC. Let's pretend 2 of its angles are right angles. I know that by let's see. I know that then these measures are going to be equal, and they're going to equal 90 degrees, right? By def of right angle. All right, you're supposed to not believe that statement.
How is the first statement are given like
some triangle exists.
Is a statement?
The triangle exists.
Itself is a statement.
Yeah.
It doesn't say like ABC, triangle ABC exists. We know triangle ABC.
No, we just know that ABC is a triangle.
Wait. We already know it's a triangle. Like that's just saying. I could have even had a picture with it, right? I could have said like, imagine triangle ABC or whatever, right? All right.
So what is our end goal?
To prove that.
My goal is to prove that triangles have at most one right angle. So what I'm doing is pretending the opposite of this for a minute. Just for a minute. All right? So let's say it has more than one right angle. Let's assume the opposite of what I'm trying to prove. It's not going to be possible, and that's what I hope to show. Let's see. I know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to what? Well, we're gonna say it's equal to 180 for a minute. We're gonna show that it can't be by trisum theorem. Right? We know that the interior angles of a triangle add up to 180 degrees. Okay, so by substitution, let's do some substituting. Oh, man. Let's do some substituting and solve for the measure of angle C. So you guys do that. This way. She's not here. Actually, she's ill today. Thank you. Don't worry, internet friends, we're still here.
Why don't you drop the part out?
Because this is the best part. Because this is when I'm gonna drop some knowledge bomb, and then the people that waited this whole time just be like, what? Crazy. So. All right. So. We're back here, friends. All right, so if I substitute, what happened when you guys substitute? Anthony, do you do the substitution?
Measure angle C equals 0.
Yeah, I was here for substitution with the Indiana Jones thing.
Yeah, substitution, right. So if I substitute, I plug in 90 for both of those. Then by subtraction, I get measure of angle C equals 0 using subtraction property, right? And how do you guys feel about that?
I think it's only by.
I don't. Yeah, that doesn't work.
That should just be like, what?
That's still lying.
Right. I wish I could I need to have a soundboard where I can just play the Metal Gear Solid guard alert sound right, I don't know, I can't simulate that noise with my voice, but that's what I'm imagining right now. This should just be no, this is impossible, right? That's what we would feel when we see this.
You should draw the triangle.
And draw the triangle. Yeah, it would be two 90-degree angles and no, I don't know. Two 90-degree angles, and then the 0-degree angle for the other one. Yep. So that doesn't work out. That's impossible. So I would say a triangle can't have an angle measure of 0 degrees. So this contradicts our assumed information. All right? This contradicts our given information, given or assumed info, right? And why does it contradict that? Because triangles can't have a 0-degree angle. It would just be like,
does it smell good? It's because of him. What you do? What is that?
so anyways, yeah, let's put whatever
That smells good.
smells good away. All right, so therefore, since my assumption was false, it must be true that triangles can have at most, any triangle has at most one right angle. All right? Because our assumption was false. Okay? Or you could say proof by contradiction. All right, so Anthony, I agree, you should have been that doesn't work. Because for a minute we were pretending it did to show that it didn't, to show that we were right. Yes, question, comment?
Do this to make sure that we never.
No, this is actually, well, what happened was I did prove what I set out to prove. I proved that triangles can have at most one right triangle. The way I did that was by pretending they could have more for a minute and show that it doesn't work. Okay? Well, sometimes proof by contradiction will be an effective means to show something where it might be even faster than the alternative. All right, here we go. So let's talk about relating side length and angle measure. All right, so you guys, you can draw. All right, Anthony, you with me here? So let's draw a scalene triangle. All right, so scalene. All right, so just everyone draw like their own triangle. Oh, obtuse? Oh, my bad, my bad. Ladies, gentlemen, please.
I think we should make all three sides.
Yeah, maybe make all three angles obtuse. Yeah, that's a good one. This angle I drew past the 90-degree point in my mind.
That's assumption.
So let's see, triangle ABC. Now it says find the largest angle. What's the biggest angle in this triangle? Angle B is the largest angle. All right? And find the longest side. Which is the longest side?
AC.
AC, I think I agree. Right there, right? Okay, all right. That seems to make sense. Then it says find the smallest angle. Who's the littlest? Oh, it's so adorable. Yeah, angle A is the littlest angle. Who's the shortest side? BC. Now, what do you notice?
That means the corresponding sides of the angle is going to be measured.
It appears as though the longest side
As the corresponding
is opposite of which angle?
B.
The biggest angle. All right, Anthony, you with me here? Right? Does that appear to be true? Does that feel like it would make sense? The biggest angle, opposite that would need to be the biggest side. And then similarly with the smallest side is opposite of, man, I gotta learn to write better, of the biggest angle. It's a drawing tablet, but you can write. Maybe I'm just drawing. That's what I'm doing wrong, guys. I'm drawing the letters instead of writing them. Oh, man. That would have been better. That would have worked. So this is working towards kind of what we're going to see in these next two theorems. The theorems. Oh, wow. That is weird. So let's see. Pulling up. Yeah, so you guys got these theorems in front of you already. Our internet friends, they're on like a 5-second delay here. Uh-oh. Oh, mouse died. No, I got to use the trackpad. So Lauren, so here's two theorems. The triangle longer side theorem. What a great name, really. If one side of a triangle is longer than another side, then the angle opposite the longer side, right, gentlemen, ladies, is larger than the angle opposite of the shorter side. So here 8 is bigger than 5, therefore angle C is going to be bigger than angle A. That's the claim. If you want proof, apparently example 43 on page 342. We'll do that, or you might do it. Then there's the triangle larger angle theorem. So notice the only difference between is side and angle. Which says that if one angle of a triangle is larger than another angle, all right, that the side opposite the largest angle will be larger or longer than the side opposite the smaller angle. Does that feel true? Right? I mean, does it at least pass like the believability test for like, I could see that. I could see that. Actually, wow, guys, this next proof is going to not only be a proof by contradiction, but a proof using cases.
Oh boy.
We're going to prove the second theorem there. Yeah, you can follow along and do what you can. Yes, sir.
I can throw all these.
No. Nope. Nope. All right, so it says, we're trying to prove, so we're assuming angle A is bigger than angle C. So angle A, we're pretending is bigger than angle C. Anthony, please stop, my friend. So if angle A is bigger than angle C, we're trying to prove that BC is bigger than AB. We're going to do a proof by contradiction. All right, so the givens we've got. Gimme. Gimme, gimme, gimme. And we're going to do a proof by contradiction. Let's assume, all right, so this is going to be an assumption. Let's assume that BC is not, this is a hard symbol to write, not bigger than AB. That's the not greater than sign. All right, so that's what we're assuming. I don't believe this is true, but we're pretending, guys.
Wait, are we supposed to write the opposite proof or a proof?
We're doing a proof by contradiction. So the way I'm proving this is pretending that it's not true and showing that that will result in something that's impossible. Like Darth Vader being Luke Skywalker's dad. Right? Luke would claim, that's impossible! Right? That's what Luke would claim. At least that was internally contradictory in his own mind. So let's assume this. Now that actually breaks into two cases. All right, so I'm going to have case one. All right, case one, if it's not greater than, then that means it could be less than. Less than AB, right, Tyler? Right, Anthony? My friends? So let's assume that, all right, that BC is less than AB, all right, because that would be one of the cases for, what is the name of that? Well, this has two possible outcomes. If it's not greater than it, it's either going to be less than it or equal to it. All right, so that'll be case two. Case closed. All right, if BC is less than AB, then that would suggest that the measure of angle A is got to be less than the measure of angle, the one opposite of that one is C. Right? Be careful, Tyler, with your less than signs and your angle symbols. This would be concluded by the triangle longer side theorem. Right? And is the measure of angle A less than the measure of angle C? No, because I specifically started by saying that wasn't the case. So this is false. False. All right? That doesn't work. I don't know. I'm just putting a crazy exclamation point there. It'll kind of be in our conclusion that we'll end up making that claim. All right. So case one ends up with a contradiction. What about case two? Could it be true that those two things are equal? All right. If they're equal, if BC was equal to AB, what could you tell me about those angles? If those sides were equal. Those angles would be equal. Man, wow, with the save measure of angle, those would be equal by the base angles theorem. However, that can't be true. Why can't this be true? Why can't those be equal? Because I started with the fact that the A was bigger than the measure of angle C. Can't be true. All right, so the two cases that I had ended up with falsehoods. Therefore, I would say that BC must be greater than AB. And the reason is proof by contradiction, or that our assumptions resulted in a contradiction. Sure. Yeah. All right. Now this is like a completely new way of proving things, so I realize it's a little bit weird, but does it make sense? We temporarily pretend something is true, show that it can't work. Yeah, it's like opposite day. Yeah. Yeah, it's not enough to look like Squidward. You gotta act like him too. So, guys, I really like this artwork right here. Are you guys digging this artwork of this mountain? I know it's way better in color here.
Yeah, I like how the one mountain is really dressed. They're all.
Oh, they're all rounded. Yeah, you're right. Wow, I really like these trees. I feel like. Oh, right. It was discovered by Anthony. I forgot, and it is Pointy Mountain. Yeah. Wow, I love it. Actually, wait. No, wait a minute. I'm glad you called it Pointy Mountain and not Mount Anthony. Oh, those would be like our rivals or something. I'm assuming, right? Yeah. Who's our school's like biggest rival? Wow, there you go. So thank you, Anthony, for naming it Pointy Mountain. So it says you were constructing a stage prop. Oh, I was hoping this was just like a pseudo-realistic world. That shows a large triangular mountain. The bottom edge of the mountain is about 32 feet long. That is a massive prop. Wow. The left slope is about 24 feet long. Okay. And the right slope is about 26 feet long. List the angles in order from smallest to largest. Who's the smallest, most adorable angle? Who is it? The smallest angle will be opposite the smallest side, so angle L, man, we have less than signs, angle signs, and L, man. So L is the smallest. Who's the middlest angle? Angle J, I guess I'm not talking about measures, I'm just talking about angles. And who's the grande angle? Angle K. Yeah. Isn't that nice? It's kind of like a nice little theorem there. And this had like a adorable artwork. I feel like I want this to be in like a flip book or something. Or it also reminds me of the artwork in Super Y, the TV show, when Wyatt and his friends, the super readers, go to no, never mind.
Oh, I know that show.
Yeah, my kids
and
like
I go through the books and stuff.
Yeah, and they're like pop-up books and they're all flat artwork. Like, yeah. Super readers to the rescue. All right, it's time to fly. Example 4, ordering side lengths of a triangle. Okay, so here we go. List the sides of DEF in shortest to longest. I'm sorry, guys. I know it's hard to do this without like a mountain or a reason to do it, but let's do this anyway. Could we figure out the measure of angle F? What's that going to be?
180 minus 46.
46? I don't know. Let's see. I'm slow with the maths here, friends. So 51 plus 47 and 40 would be 91. Plus the 7 is 98. Looks like 82. So 82 degrees. That was true by triangle sum theorem and subtraction property. So what side lengths? Which is the shortest side? DF. It's opposite the 47. The middleist side, EF. And the O for the longest side will be Ed. We'll call him Ed. Yeah. Right? So it's kind of a easy enough theorem to apply. Now, guys, we talked about this one actually a little while ago. I might have spoiled this one for you. The triangle inequality theorem.
That's not fair.
Yeah. So, not every group of 3 segments can be used to form a triangle. Ooh, guys, I wonder. Oh, I like this. I like this. All right. For example, 3 attempted triangle constructions using segments with the given lengths are shown below. Only the first group of segments forms a triangle. Okay. All right, let's see. I'm gonna do the on-screen display. You don't see it, but my viewers will. Let's see, video source capture device. Let's get that, and here we go. All right. So my students, you guys can look back at me. This is the one where, all right, I'm on the top left of the screen. That's okay. Let me move myself down to the bottom right. All right. So this is the idea. Imagine from elbow to elbow. That's like one side of a triangle. Also, I know I'm pretty strong. I know. And imagine that my forearms are the other sides of the triangle. If my forearms are too short, compared to the other side, it'd be like this, and like I couldn't form a triangle. You know? Yeah. Right? So friends at home, right? Triangle inequality theorem, right? Yeah, they've got a video. I'm gonna like picture in picture. I know you can't see it up there, but don't worry. Believe me, you'll see it on YouTube. This is gonna go viral. All right, triangle inequality theorem. If my forearms were exactly the same length, it wouldn't form a triangle. It would just form a line, right? You guys agree? So what I need is just like gorilla forearms. We dressed up. Here's a story time. This is actually perfect since I've got the video playing. We dressed up my youngest son as a gorilla for Halloween. This was just a couple days ago. And he really likes toy dolls. Like he found like this baby when we were like hanging out, passing out candy. And so like I got pictures of him. I'm like, we dressed him up as a gorilla. Little did we know he wanted to be Harambe. And so like I posted it on one of my friend's walls. He was always posting the Harambe memes. You know, and then shortly after that, he starts like flailing the baby around, and so I got video of him like throwing the baby across the room and like slamming it, and I posted that on his wall, and I was like, this is getting a little too real, and so it was a toy baby. He has not observed that behavior in our household. We don't flail babies around. I promise you. Not on the internet, but yes. All right, so let me get rid of this display device here. And yeah, bye. Okay, so triangle inequality theorem. Yeah, gorilla arms, Harambe. You need the 2 arms to be bigger than the third side, right? So 4 plus 2 has to be bigger than 5. 2 plus 2 is less than 5, and the fingertips don't even reach. And then if they add up to being exactly 5, that's when like they would barely reach, but it's not a triangle anymore. It would just be like segment addition postulate sort of thing.
What if like one, like in the second example, the right side was 4 and the other side was still 2? They still
4 and 2?
unless you pivoted it, like if they're staying with that.
No, if this was 4, then 4 plus 2 is 6, which is bigger than 5, and it would reach.
But you'd have to like move it on that.
Right. Well, it would swipe at a new arc, and it would be able to intersect and make a possible outcome. So, anyways, yeah, I'll have to show you guys the footage of little 2-year-old Harambe throwing a baby. So, triangle inequality theorem. This one, yours doesn't have color. My apologies. But here we go. AB plus BC have to add to be greater than AC. AC plus BC. So AC is purple plus orange has to be bigger than blue, and blue plus purple has to add to be greater than BC. All right? Otherwise, you don't have a triangle. That's what we're looking at. Let's see, last example, example 5. That's as far as we'll get today. And we're going to apply the triangle inequality theorem to find possible lengths of a triangle. Okay. So a triangle has one side length of 14 and another side length of 9. Describe the possible lengths of the third side. Okay, so the third side is some unknown side to us. Okay? All right, where are you getting that? Or what are your thoughts? Sorry, I couldn't hear you. I was signing a bathroom pass.
So you add.
Okay. Well, is it less than? Or greater than that? The other two sides, sorry, yeah, which is it? No, you were right. X would be less than the sum of the other two sides. You're right. My bad.
Well, what would be like?
All right, so yeah, so the, sorry, what was your comment,
It would
Jack?
also be that, like, if X is less than greater than 6, that it would work, or 5, that it would work as well.
Yeah, do we have another constraint here?
Would it be between like 5 and
What about X plus 9? How does that have to compare to 14?
greater than? Oh,
Right. So if I subtract 9 from both sides, X also has to be greater than 5. So right now I've got X is between 5 and 13. Now,
Wait,
what about the other one? Did I need to write X plus 14 is greater than 9?
hold up. 14.
Sorry. Yeah. Wow. Yes, with the save significantly. All right, so 14 plus 9, what are you suggesting? It's equal to?
It's 23.
23 sounds a little better. Now, do I have to do this one? Why don't I have to consider that one?
It is.
Because X subtract 14 from both sides, 9 minus 14, what's that, negative 5? That ends up not even being an issue. And also, I wasn't considering negative side lengths to begin with. All right, well, thank you for watching, Internet friends. Have a great day.